Okay, I just want to spend a couple days on linear and absolute value inequalities. This was unit 3 that we didn't do. We cut this out at the beginning just to make sure we had time to get through the more important items first. So I just want to hit this fairly quickly. There's interval notation, and we've talked about that some, but when you get into upper math classes, we use interval notation more. So it's pretty easy. Inequality notation and interval notation, you should be familiar with both of those. So if I was to say x is less than a number, say any number, and I just use a for that, interval notation is a parentheses and brackets. Parentheses means it's an open interval. It does not include an endpoint. And brackets means it includes the endpoint. It's a closed interval. So x less than a means I would go from negative infinity to a, but it does not include a. And it never includes infinity. And the one thing you have to make sure when you use interval notation is that you write the values least to greatest. You should do that with inequalities as well. So x greater than a means you're going to start with a and you're going to go to the right forever. So from a to infinity. X less than or equal to a, you're going to go from negative infinity to a, and it's going to include a. A greater than, or x greater than a includes a, goes towards infinity. If we want to say x is a value between a and b, but it does not include the value of a, and it does not include the value of b, we're going to use parentheses. So it looks like a point. So usually when we're using this notation, we define it as the interval, so it doesn't get confused with a point. If it includes a and includes b, it looks like that. If it does not include a, but it includes b, and if it includes a, but does not include b, it looks like that. So that's interval notation. The other thing you may or may not have seen in Algebra 2 was talking about intersections and unions. And I'm not going to stress a lot with this, it's just this is the opportunity to bring this up. If you're talking about the intersection of a and b, you're talking about a and b. And that symbol reminds me of an a. It means the elements that are common to both. In inequality, a lot of times we refer to it as overlapping. This union, where the symbol looks like a U, is an OR. So it means elements in set A or set B. So we're just going to do some problems with these on Wednesday next week, or Wednesday and then Thursday, and then a quiz on Friday for the last day of the semester. So in solving linear inequalities, I have the inequality 3, quantity x plus 2 greater than 12. Some of you like distributing that 3 in, and you can. I look at it and say, well, I can divide by 3, because what that's going to do is that's going to make that an integer, and it's pretty easy. So I'm going to divide both sides by 3, and I get x plus 2 is greater than 4. Subtract 2, I get x is greater than 2. So in inequality notation, it's x greater than 2. In interval notation, I'm going to start at 2 and I go towards infinity. The next example, I have 2x minus the quantity x plus 3. So I cannot divide by this 2x because that's a minus sign. So I'm going to distribute that negative. So I have 2x minus 3 less than or equal to 4x minus 8. Now just a little bit of algebra. 2x minus x is x. And then there's different ways that you can do this. I'm going to go ahead and subtract 4x from both sides. So I get negative 3x. And I'm going to add 3 to both sides. So I get negative 3x is less than or equal to negative 5. And I'm going to divide by negative 3. And if you remember from Algebra 1 and Algebra 2, if you divide or multiply by a negative number, you flip the inequality. So this is going to be x is greater than or equal to 5/3. That's inequality notation. I'm going to write it in interval notation. It includes 5/3 and it keeps going to the right. The other type of inequality that we do, that you would have done in Algebra 2 as well, is a compound inequality. A compound inequality is an intersection. And it can be written like this, where you have 2x plus 5, the variable's in the middle, and it's sandwiched between a number on the left and a number on the right. So what happens here is I'm going to subtract 5 from the middle, but that means I have to do it from the right and from the left. So we get negative 2 is less than 2x less than 8. Now I'm going to divide by a 2. So when I divide by a 2, negative 2 divided by 2 is negative 1 less than x less than 4. That's inequality notation, but in interval notation, it's negative 1, does not include negative 1. Oh, I missed that. That's it, less than or equal to, less than or equal to, less than or equal to. So then it includes 4. And there is a way to check these on the calculator. I'm not sure if you're aware of it. It's, I go to my y equals. And let's look at this first one. 3 parentheses x plus 2. To get the greater than, I do second and math. And the greater than symbol is number 3. And then 12. And the way I check these is I go to the graph of this. I'm going to hit zoom 6 to get this back to a normal window. And I'm saying from 2 to infinity, so you can see right here at 2, and it keeps going to the right. It's not a perfect way to do it, but it gives me an idea how to check my work. If I want to check this one here, the compound inequality, it has to be done a little bit differently. I'm going to say 3 less than 2x plus 5. But then I cannot just do another inequality. This calculator won't let me do that. So I'm going to go to second math, logic. I want the and. I have 2x plus 5 less than or equal to 13. And then when I go to my graph, it's shaded between the negative 1, so it goes from negative 1 to 4. It's a great way if you're doing a standardized test and you have a calculator and you want to check your work. That's one great way to do it. Next, we're going to do absolute value inequalities. So when I do when I teach most things, I do with 4 steps, because 4 steps is reasonable to remember. Any more than that, it gets confusing. So my first step is to isolate the absolute value term. I'm going to write 2 inequalities. It's either a union or an intersection. A union is an or, and an intersection is an and. I'm going to solve them and I'm going to check. So to isolate this absolute value term, I'm going to have to add the 2 to both sides first. Okay, now my absolute value term is isolated. And I'm going to write my 2 inequalities. This is a less than, so it's an and. So that means I'm going to have 4x plus 7 in the middle, less than or equal to 11 on the right-hand side, and then greater or equal to negative 11 on the left-hand side. I'm going to first subtract 7. And I get negative 18, less than or equal to 4x, less than or equal to 4. I'm going to divide everything by 4. And I reduce fractions. Negative 18 divided by 4 is negative 9/2, less than or equal to x, less than or equal to 1. So in interval notation, it goes from negative 9/2 and it includes that. And it goes up to 1 and includes that. So there's my answer. And I can check that in the calculator as well. to get the absolute value bars, there's several different ways to get it. I'm going to go to math, over to number. Absolute is the first term. I'm going to type in exactly what I have on the paper. Oops. Less than or equal to 9. So my answer is between negative 9 halves and 1. So negative 9 halves is negative 4.5 and 1. So it looks like it checked out well. The second example I have to isolate by dividing both sides by negative 2. So I get absolute value of x minus 6. When I divide negative 10 by negative 2, I get a positive 5. But remember, when you divide by negative, you flip the inequality. Now, this is not a compound inequality. This is a union. This is an OR. So I'd have x minus 6 greater than 5, or x minus 6 less than negative 5. I'm going to add 6. I get x is greater than 11, or x is less than 1. Now the problem I have here, this is saying x is greater than 11, so it's going from 11 to infinity, and then negative infinity to 1. But I want the smaller numbers on the left-hand side, so it really needs to be written like this. And if some of you are familiar with it from Algebra 2, if your teacher did this, it's an OR statement, so it's a union. And you can write this either way. It really depends on what you're more comfortable with. And that's everything on inequalities that we're going to do this year.